Hey, this is Mr. Hendrickson, and this is your laser targeting pre-lab. What you see in front of you are the materials that you will find at your lab table needed to complete this lab. Notice in the handouts you will have a laser targeting sheet, which is a series of columns with different scores. Your job will be to ultimately hit the 10 out of 10 on the very first shot to get 10 points. We'll talk more about that later. You also will have 4 small half sheets that will designate where you will be positioning your mirrors. And then you will also have a firing zone which designates where you will actually shoot your laser from. You should have a small roll of tape that you'll use sparingly, maybe some scissors, some mirrors, protractors, rulers, and meter sticks. So the first part of this lab is to find the actual target sheet. There's a portion on the bottom where you'll fold it, and then you're going to pick somewhere along on your table where you will tape down that back folded piece so that the target itself will stand up, probably with a little help from one of your partners. So get some tape, pick a nice spot on your table where you will eventually be hopefully hitting that target with the laser beam. Again, you notice it does not stand up on its own, but certainly you or one of your partners can help hold it up. The next part of the lab is to find those half sheets to determine where we will be placing our mirrors to get our 4 incident and reflected rays that will eventually hit that 10 out of 10. So the next thing you're going to want to do is find a meter stick, and you are going to line that meter stick up with the center of the target. That's where your last reflected ray should be traveling off of the mirror, and again hitting dead center 10 out of 10. So what you want to do here is you want to line up your first small half sheet. The first partner will do this, and you want to line up the ruler with the back of the mirror and with the normal line. This is going to be the path our reflected ray takes. Once you have that edge of the ruler lined up from the center of 10 out of 10 to where the back of the mirror and the normal line meet to make an angle with the normal line, you'll go ahead and secure down that half sheet of paper. And again, that's the path your reflected ray is going to take. Go ahead, and what you'll want to do there is grab a pencil, and you'll want to go ahead and trace that ray onto the actual sheet of paper, and again make sure it makes an angle with the back of the mirror and the normal line. So the next step is, once you have that reflected ray drawn on your page, you need to go ahead and measure what the value is of that angle that it makes with the normal line. In this case, I find the value of that angle to be 39 degrees. Now we know that the law of reflection tells us that the angle of reflection must be equal to the angle of incidence. So that means that I need to create an incoming ray that also makes an angle of 39 degrees relative to the normal. So when I do this, I go ahead and simply mark it with my protractor, and I make sure I draw from that mark, that 39 degree mark, to where the normal line and back of the mirror meet. So now I've got my 2 angles drawn on my over my wooden block. I make sure I label the angles that these rays make with the normal line, and then I go ahead and I would sign under member signature for my work. And again, split this work up. Each of your partners should do their own mirror positioning. Now I know the direction my incident angle is coming from. So you can see I have my meter stick set up. Now I know where my next mirror will be. And again, I continue going from here just like I did with the first mirror. And you keep working your way back, placing 3 more mirrors and eventually the firing zone. Okay, here's the next 3 mirrors played at 10 times the original speed. Again, just take notice of what I do here. Each time I find the reflected ray, measure the angle, drop a protractor over the top, and I also measure the incident angle. I use that line created at the incident angle and follow it back with the meter stick to find where the next reflected ray is. Again, use a protractor, find those angles, use the law of reflection, find the reflected ray again, and just keep following this process. Eventually, that gets me to this point where now I know where my very first incident ray needs to come in. So at this point, I take my very last mirror I placed, which ends up being the first mirror where the reflection occurs, and I take my ruler or meter stick and align it with that first incident ray. I note now that my laser needs to be shot along this first line and strike the first mirror in this fashion so that it will undergo 4 consecutive reflections and eventually hit the 10 out of 10 on my target. So I now align where I want my laser to be fired from. There is a initial little line there. Your teacher will make sure that the laser itself is lined up with that beam, and then we'll turn it on and fire it at the target. Once everything is secured to the table, you'll want to take your mirrors and line them up with the pictures of the mirrors on the half sheets. Make sure the front of the mirror lines up with the front on the description and the back lines up with the back. Again, carefully place these on each piece of paper. One thing you want to take note of is that in this particular case I have 2 tables. Right now my measurements are perfect for how the 2 tables are oriented. If for some reason I was to shift one of these tables, all of those measurements would be off. You need to be extremely careful that you don't shift the tables at all during this course of the lab. Or find a way that you can guarantee that the tables or table won't shift. And then at that point your teacher will align the laser beam with the first mirror, turn the lasers on, and someone from your team will hold up the target, and hopefully you hit a 10 out of 10. So during the course of this lab, you're going to need to make some decisions that will impact the success of your hitting the target. So as you go to create your setup, there are a number of things that you need to think about. One is simply, how do you orient the mirrors? Should you set them up rather close together, something like this, where each mirror is, 30 centimeters to 40, maybe even 50 centimeters apart? Or could you do something where you take the mirrors and spread them out very, very large distances? So let's say instead your team opted to put a mirror on the far table, and then the table next door to it a few meters away, and then a table across the room maybe 3 or 4 meters away, and then another mirror another 2 meters away. And then eventually the target was across the room another 3 or 4 meters away. Do you think you would have success with such a setup? Keep this in mind as we go forward into the lab tomorrow. In addition to the spacing between the mirrors, you'll also need to make sure you are very careful with orienting the actual mirrors themselves so that your angles of incidence and reflection are in a specific range. What we're going to find is that your range of incidence and reflection can be anywhere from 0, which would be striking straight away along the normal line, to 90, which would be striking along the edge of the mirror. When you have angles of incidence or reflection that are very, very large or very, very small, you can have large margins for error. What you'll notice about my measurements is that they all fall in approximately the 30 to 60 range. That first measurement was 50, the next one was 56, this measurement here was about 39, and my last one I believe was 38. There's also a really simple technique you can use to determine if your target is actually aligned with the initial laser. If I was to shoot a laser at that face right there, where would the laser go after it reflected? Think about that when you do the lab tomorrow. So here we are looking into the first mirror, and you can see a series of mirrors following behind it. Those are the mirrors that we're going to use to continually reflect. Take a look as I move the target around. You can actually see the target moving in my mirror as we look into it. What does that tell us about our alignment and how this is going to work out for us? Take a moment, think about it. That might end up helping you for the lab tomorrow. Hopefully the tips and tricks and lab setup itself gave you a good idea of how this lab will happen. If you get confused along the way, please make sure you read the lab and of course ask your instructor for help. Good luck and thanks for watching.